everyone. Today we will start with a mathematical tool to understand solo growth model. Let's start. Let's take x equals to xt. It is the amount of x at the time t. If we differentiate with time, we'll get x dot t. That means the amount of x that will change over the time t. I hope you can see this. Suppose we take value of x at the time t to be 10 and the amount of x that will change over the time t to be 2. So let's take x here and x naught t here. So if the value of x is 10, then x naught is 2. If it's 1, then it will be 2 by 10, that is 0.2. And if it's 100, then it will be 2 by 10 into 100, that means 0.2 into 100, that is 20%. That means these all are actually x naught by x, right? So we can state this as the rate at which x changes over time. Suppose if x naught by x is greater than 0, that means it is increasing. We can also define it as that x is growing over the time t at the rate x naught by x. That means this is the growth rate of x. Now we take Vt equals to xt into yt. That means growth of V will be depending on growth of x and growth of y. Let's see how. Now we will differentiate with respect to t. We will keep this one variable constant and we will differentiate the other, and then we will keep x as constant, then we will differentiate the other. Therefore we know when we differentiate, we put x to the power x naught, right? X naught equals to y into x naught, this is v naught, equals to y x naught plus x y naught. Then to find out the growth, we have to divide this with the whole main equation, that is 1. That means v naught by v equals to y x naught plus x y naught divided by x y, right? This is the growth rate of v, as we have already learned it. We can cut this and cut this, right? Then we will get x naught by x plus y naught by y. That means the growth of v, the growth rate of v will be depending on the sum of the growth rate of x and y. What I will said, I will just write it. The growth rate growth rate of V is equal to the sum of the growth rate of X and Y. That means when we have multiplication, the growth rate of V will be the sum of the values that have been multiplied, right? Suppose we take division here. Let's see what will happen. Vt equals to xt by yt. Then we'll again differentiate, we know it, with respect to time. If we differentiate this, then y differentiating x with respect to time minus x differentiating y with respect to time by y square. Normal differentiation, we have learned it. Then this will be v dot equals to y x dot minus x y dot by y square. If we separate this, then it will be like this. It's very basic. Then we'll cut it like this, minus by I square. Now we have to divide Vt with V. That will be equal to x naught by y minus xy naught by y square divided by x by y. Therefore we can write this as x naught y minus x y naught y square by y by x. Therefore if we multiply y, then it will be y naught y into y minus x y naught by y square into y divided by x. We cut this, then we will left with x naught minus x y by y divided by x. That simply means x naught by x by x y naught by y x. Here we will cut x, then we left with x naught by x minus y naught by y. Simple calculation. That means we can see the growth rate of y is depending on the difference between the growth rate of x and y. That means when we have division, there is subtraction, and when we have multiplication, we will have sum or plus. Now if we take number 3 as Vt equals to some constant multiplied into xt, then we will again differentiate it with respect to time. This is a constant. As a is a constant, it will be outside the differentiation. Then we will differentiate x with respect to t. Then we will have v dot equals to a x dot. Then to find out the growth rate of v, then we have to divide it with v, a x naught by a x, this one. Therefore, there is the growth rate of v. We have to cut this, its division. V naught by v equals to x naught by x. That means growth rate of v is nothing but the growth rate of x. That means growth rate of v is nothing but the growth rate of x. These are some basic mathematical tools that we will use while learning SOLOW growth model in the next video. These are very useful. We have to first learn this all what I have written, what I have shown in this video. Then we have to go and watch the video on solo growth model.